All right, so let me talk a little more about the first category here, defending Linux servers. One thing which has been a huge improvement in my classes is using the Google Cloud. Google is number 3 in the cloud infrastructure. Number 1 is Amazon. Number 2 is Microsoft, or maybe it's the other way by now. And Google is a distant third with like 5% of the market. And because they are so far behind, they're trying very hard to get more market share, which is great for me because that means they give away a lot of free service as a promotion. It also means, by the way, that probably if they don't succeed in getting more of the market share, they're just going to give up and quit in a few years. So as far as a saleable skill, you really want to learn how to use Azure or Amazon Web Services. Those are things that will directly get you a job more. However, neither of them offer enough free service that's easy for my students to get. So I use the Google Cloud, and it has greatly improved my workshops because before this, I had students who had to install VMware locally. And especially since Windows moved to the high resolution desktop, VMware just doesn't work very well at all. And VirtualBox doesn't work on many systems, and a large number of students were really unable to run virtual machines with their local computer, and that made it very hard to teach. But now everybody can use cloud machines. And so you just get a Gmail account and a credit card or a bank account, which will not be charged if you're using Linux systems, and you can just create these cloud machines for free. They give you a $300 free trial. You see I'm down to $210 left on mine. You get 1 year or a total of $300 of fake money to spend. And I got to turn off the cloud shell, which I've turned on by accident. Anyway, there we are. And then you can declare these machines. And a Linux machine only costs about $1 a day of fake money. And if you use up your money, you just make a new Gmail account, use the same credit card again, and get another $300. I've done it more than 20 times. Of course, this means that if you are really using the machine as a production server and putting important data on it and such, you're pretty much hosed when your trial comes to an end and they just throw it away. So you can't really put a production server on it for free, but you can certainly make a machine to use. For example, I've got these Debian machines, and if you just click SSH, you've got a command line on your Linux machine, which is very nice. You don't even need to have an SSH client installed on your machine. It doesn't matter whether you're using Windows or Linux or a Chromebook or anything. So it's great. And if your machine has a private IP address, which is only usable to reach other machines in the same cluster, so all the machines you create in the same group can talk to each other with no firewall between them. But to talk to the outside world, there's a firewall, and you have an external IP. So it's really very nice. And that's what I use for almost everything. If you make Windows machines in the cloud, they won't let you do it with your free trial money. So you have to spend some real money. And to make a Windows machine powerful enough to move quickly, you have to spend several dollars a day to keep a Windows machine up. So I use a local VMware machine for that. Anyway, so that's how you get a cloud machine to work on. And so in these Linux projects, first you just create a Google Cloud server. By default, you get a Debian server. It's Debian 10 now. Used to be Debian 9 when I wrote these projects, but a month or two ago, they upgraded to Debian 10. For most practical purposes, they're just the same. And then you can prove that you got it just by looking at the hardware. And the hardware is, of course, simulated hardware on the Google Cloud. So it has a distinctive name. And then you install Splunk and Suricata. Splunk is free. You do have to create a Splunk account just to get the download link, although I've had some students who don't do that. They just Google and they found a GitHub repository where somebody just posts the download links for Linux versions of Splunk, so you don't need to create an account. But anyway, all you do is make an account and go to download, and then you're just trying to get this command. There is a wget command that will get the latest version of Splunk. And it's, of course, free on Linux. The way Splunk works, which I'm very pleased with, is the free version has all the features of the pay version. The only difference is you cannot monitor a large amount of live data. The amount of megabytes of live data you can monitor is limited, which means you can't use it to monitor a real busy network without paying for it, but you can use it on, say, small trial networks. And then that way you can learn. You can learn all the features. The other way they punish you for using a free version is everybody is logged in as administrator all the time, which is something you currently couldn't allow on a production system. So anyway, once you get Splunk on, you configure Splunk to start monitoring the logs on your system. The point of Splunk is, at first, it might sound silly. You have Windows has an event logger, and it just stores the logs, and you can open a Microsoft Windows tool to view the logs and search through it. But if you have a real network, you've got a web server, an email server, a firewall, all kinds of devices, and everyone tells you you have to monitor the logs, but that is very painful to do. And the whole point of Splunk is it's Google for log data. You have a Splunk server running, you have forwarders on every device sending data into Splunk. It is your SIEM system, Security Information and Events Management. It's the #1 system in this space, used by, I think, everyone in the Fortune 100. It's very expensive to run, thousands of dollars a year in production, so they're rolling in the money and people pay that money because it's worth it. So now you just go to a website controlling your Splunk instance, you can just search for things and you'll see the events here. These are just log events coming from your devices. And so now you make an Ubuntu server in the cloud as well as your Debian server and prepare it, and then you can try logging in to your Debian server from your Ubuntu server from your Debian server, and you have failed login attempts. And you can use Splunk, for example, with the right query, and you can find those failed login attempts. So you can detect that simple kind of attack, a brute force attack. Then you can put on Suricata, which is a standard open source intrusion detection system. So it has a whole bunch of possible attacks that it can detect. And then you connect those logs, and now you can detect a SYN flood attack. So, and you can detect it in Splunk. So you get used to how Splunk works. Splunk just is a way to make it easier to search through your log data. In principle, you could just view it in a text editor or grep through it. But in practice, at scale, it is much better to have a product to organize and index that data and have a single point, and that turns out to be really worth a lot of money. So then you move up, you set up a Drupal server by copying one of mine. In the Google Cloud, you can't do this with a free account, but if you pay Google some money, you can create one of these cloud servers and save an image and then publish it so everybody can just copy it. So here you copy my machine, Sam's Images, purple1.tar. I made a workshop called Purple Team CTF where I used this. And when you install that, that is a Linux machine running an old vulnerable version of Drupal. Drupal is a WordPress competitor to make websites, and it is famously very vulnerable in its old versions. There was a whole series of disastrous vulnerabilities, and this is a very old version with quite a few vulnerabilities. So once you've installed it, you can then, it's also running Splunk, so you can track it, and now you can send some suspicious traffic and see it hit, and then you can install Metasploit and attack it with that. Here's Drupalgeddon, which is not Metasploit, it's just a Python proof of concept code, one of the famous Drupal vulnerabilities, and you can send that and detect it. And then you can use Drupalgeddon 2 from, I think, Metasploit. Or maybe you had to install Ruby. Anyway, so you can practice, then you install Metasploit. By the way, I used to use Kali, a local security distribution for a lot of projects. But when I moved almost everything to the cloud, I quit using Kali because I really don't need all the hundreds of tools in Kali. I really need just 2 or 3 tools at a time. So I like to use just a plain ordinary Debian server and just install those tools. This way you can make a quick throwaway cloud server to do a pen test or CTF and then throw it away when you're done. So I've gotten away from specialized security distributions. So you can just install Metasploit easily on your server, and then you can send Drupalgeddon attacks from Metasploit and see how they look in your detection system. So this gets you used to attacking and defending. And the last tool in this category is OS Query. OS Query is a Facebook tool which serves the purpose of letting you have platform independent queries. So you install this OS Query, which you can put on any operating system, and then you have a database of information, sort of like the event log, and you can now query it to see what is going on that system. So you have a lot of tables available. You can see all sorts of information. You can see the software repositories on your server. On a Linux server, you can see the ARP cache, logged in users, OS version, which SUID binaries, which are privilege escalation risk, and so on. So you can write scripts, and other tools use OS query to make queries to question. And this is a big part of incident response. You have some kind of event where there's a violation of security policy, like an antivirus alert goes off, and then you find some evidence of some malware. And now the question is, which machines have the malware? And you want to have a central system you can use to press out queries to say, look for these files and registry keys and network connections and test every machine to see if they have it. And we'll talk about tools like GUR that help doing that later. But what's working underneath them is something like OS Query that has a nice system of asking all your machines a question like, do you have this registry key? Do you have this file? Are you running this process? Things like that. So OS Query is one of the tools, and you can configure it to do file integrity monitoring like Tripwire, where it will check to see if certain files have been changed, which is, of course, evidence that someone has been installing unauthorized software or a rootkit or something. Another common question you'll have of machines is, what new software have you installed? That's a big part of threat hunting, just looking for suspicious activity to try to see what's going on when you suspect trouble on your network. And I should mention, this is the whole philosophy of modern incident response. Maybe 8 years ago and earlier, we believed that we could protect networks by keeping them clean. Like, for example, New Zealand right now has no coronavirus because they closed their borders. They treated all the people that were sick. Nobody new can come in. And so now they just have a clean place with nothing to worry about. And that's the way we used to try to make our networks. We'd have an IDS and a firewall on the edge, and all the machines inside the company were real machines on the desktop, and nobody could bring in machines from home or anything. And we regarded it as a clean space because we kept the borders secure. But now that everybody has laptops and cell phones and USB drives, and everybody's using cloud services and everything, we don't really have a border and a clean space inside. We have to switch to the zero trust model, where it is entirely possible that some of the machines in your network are infected and under hostile control, and you can't ever get that down to zero. So you have to switch to a different theory where you're going to constantly monitor your network, try to detect the outbreaks of infection that occur and deal with them. And that's incident response, where you still have firewalls and such, but you know they're not perfect, and you know some attacks are getting through, and you have another team of people trying to detect the attacks that got through and stamp them out and limit the harm they do. And that's where we are. So let me put this video up.